Today, we're keeping things simple and fun. No complex algorithms, no advanced math. We're going to use the buttons on an external Bluetooth joystick controller to drive the mBot2. We'll build this in 3 stages. In stage 1, we'll get the basic controller commands working. In stage 2, we'll fix an important problem and make the robot stop when no button is pressed. And in stage 3, we'll add a speed boost feature so the robot can drive faster when we want it to. By the end, we'll have a remotely drivable mBot2 with a boost mode. If you don't have this controller yet, I've added links in the description where you can buy one. First, let's connect the controller to the CyberPi. If you've already connected this controller to your mBot2 before, it should automatically reconnect when both the CyberPi and the joystick controller are powered on. If this is your first time connecting them, keep them close to each other, then press and hold the Bluetooth button on the controller. After a few seconds, it should automatically connect to the CyberPi. Now let's move into mBlock and start programming. Before we use the controller blocks, we need to add the Bluetooth controller extension. Click on Extensions, search for Bluetooth controller and click Add. Once it's added, you should see a new Bluetooth controller block category. One important note, these blocks only work in upload mode. So if the blocks look grayed out, switch from live mode to upload mode. Now we're ready for stage 1. I will make the full block program available in the Learn as you Explore hub. It's free to join, so sign up today and get access to this code and video for this lesson. For stage 1, we'll keep the program as simple as possible. The program starts when button B on the CyberPi is pressed. First, we print a message. This helps us know that the program has started. Next, we create 2 variables. The first one is forward-backward base speed. This controls the speed when the robot moves forward or backward. The second one is turn base speed. This controls the speed when the robot turns left or right. I've set the forward and backward speed to 30 revolutions per minute and the turning speed to 20 revolutions per minute. Then we start a forever loop. Inside the loop, we check which controller button is being pressed. If the left arrow button is pressed, the robot turns left at the turn base speed. If the right arrow button is pressed, the robot turns right at the turn base speed. If the up arrow button is pressed, the robot moves forward at the forward-backward base speed. And if the down arrow button is pressed, the robot moves backward at the forward-backward base speed. That's it for stage 1. Very simple. Let's test it. I've already pressed button B on the CyberPi, so the robot is waiting for controller commands. Now I'll press the up arrow button. The robot moves forward, but notice the robot keeps driving forward. If I press a different button, the robot changes direction, but again it keeps doing that motion even after I let go. So the controller is working, but our program has a problem. We never told the robot what to do when no button is pressed. Right now, once we send a movement command, the robot keeps following that command until it receives a different one. So in stage 2, we'll fix this by making the robot stop when no direction button is pressed. For stage 2, we need to detect when none of the 4 direction buttons are being pressed. The 4 buttons we care about are up, down, left, and right. To detect this, we first check if any of these buttons are pressed. We do that by chaining them together with our blocks. So the condition is checking. Is the down button pressed? Or is the up button pressed? Or is the left button pressed? Or is the right button pressed? If any one of those buttons is pressed, this OR condition returns true. But we actually want the opposite. We want to know when none of them are pressed. So we put a NOT block around the entire OR condition. Now the logic works like this. If any direction button is pressed, the OR condition is true and the NOT turns it into false. But if none of the direction buttons are pressed, the OR condition is false and the NOT turns it into true. So this condition becomes true only when no direction button is pressed. And when that happens, we stop all encoder motors. The rest of the program stays the same. Now let's test stage 2. When I press a direction button, the robot moves in that direction. And when I let go, the robot stops. That's exactly what we wanted. Now the robot feels much better to control. But there's still one thing we can improve. The robot is a little slow, especially if you want to drive it across a longer distance. So in stage 3, let's add a boost mode. For the boost mode, we'll use the plus button on the joystick controller. We'll also add a few new variables. The first new variable is boost factor. This controls how much faster the robot should go in boost mode. I've set it to 3, which means the robot will drive 3 times faster when boost is active. The next 2 variables are actual forward-backward speed and actual turn speed. These are the speeds we'll actually send to the motor blocks. Why do we need these? Because sometimes we want the robot to use the regular base speeds, and sometimes we want it to use the boosted speeds. So these actual speed variables will let us switch between normal mode and boost mode. At the top of the forever loop, we add a new if-else block. The condition checks whether the plus button is pressed. If the plus button is pressed, we set the actual forward-backward speed to the forward-backward base speed multiplied by the boost factor. We also set the actual turn speed to the turn base speed multiplied by the boost factor. So with our current values, the forward and backward speed becomes 30 times 3, which is 90 revolutions per minute. And the turning speed becomes 20 times 3, which is 60 revolutions per minute. If the plus button is not pressed, we set the actual speeds back to the regular base speeds. After that, the rest of the program works the same way as before. Now let's test the final version. I will make the full block program available in the Learn as you Explore hub. It's free to join, so sign up today and get access to the code and video for this lesson. First, I'll drive the robot normally. It works just like stage 2. Now I'll hold the plus button while driving. The robot gets a speed boost, and when I let go of the plus button, it goes back to the regular speed. So now we have a simple remote-controlled mBot2 with a boost feature. If you got something useful from this video, please hit the like button and subscribe for more robotics projects. I hope you had fun with this simple, easy, and practical project. Here are some other videos you might like. Keep learning, keep exploring, and I'll see you in the next one.